Assalamu alaikum everyone, this is Fadila again, and today we're going to be solving a couple of problem sets in production equilibrium. So if any of you haven't watched my previous video, I would highly recommend watching it before coming to solve these problem sets, as these problem sets do require terms that require foreknowledge. Like you should know what isoquant curve is or isocost line is, what L star and K star or optimal combination of factors mean. So I'll highly recommend watching it before coming to this video, and if any of you are interested, I'll link it in the description below. And so without any further ado, let's begin today's video. So the first question that we have been given today is this, that we have been giving the following information for a producer, and here it is said that our max Q, that is our max production, is a function of two factors, one being labor and the other being capital, such that C equal to WL plus RK. Here C is the cost constraint for a firm, L is the labor, K is the capital, W is wage, that is the cost of labor, R is interest, that is the cost of capital. We have been told to find the optimal solution. Now the optimal solution basically means that we have to find L star and K star. All right, so just a bit of theory before we start getting into this problem. It is quite a theoretical problem. We'll go and solve numericals in the next problem, but let's just come to this preliminary problem for now to give us a better understanding. So this is our iso-cost line. As I've said, the iso-cost line is like basically the cost constraint for a firm. So iso-cost line, and this right here is our isoquant curve. That is basically an IQ curve. That is our isoquant curve. All right, so let's say this is a graph, all right, and this is our IQ curve, and this right here is our isocost line. This is our isocost line. Now, this point right here is where we can find the optimal combination of factors. That is the point at which the slope of the IQ curve will be equal to the slope of the isocost line. So, sorry, that will be isocost line, not isoquant. Yeah, my mistake. Right. So, that is, here we can find K star and L star. So basically what we need to find is, to simplify it, is that we need to find the slope of the IQ curve, we need to find the slope of the isocost line, and we then equate those two equations. So let's start with isocost line first. So isocost line. So our equation is C equal to WL plus RK. All right. Now, to find the slope, the easiest way is basically to turn into the formation of y equal to mx plus c, where basically this right here is our slope, all right? So to do that, what we do is basically we transpose c minus wl equal to rk. Therefore, k equal to minus w by r L plus C by R. All right. And this right here is our slope, right? That is basically, that is basically dk by dl, dk by dl equals to minus w by r. And this right here is the slope of our isocost line. Now, slope of our IQ curve, all right? So our IQ curve is given Q equal to f of L and K that is a function of labor and capital, right? So let's say we differentiate both these sides, like partially differentiate, all right? Now the question is, why do we partially differentiate? That'll be clear in a few minutes. So let's say we partially differentiate once with respect to L and once with respect to K. All right. All right. Now this value will be equal to 0. Now what does this exactly mean? Again, a bit of theory again. So the basic theory of an IQ curve is that for each point on that said curve, the level of production will be the same. All right. Now this right here is our marginal production with respect of L. And this right here is our marginal production of K. Since marginal production is basically the first derivative of any product function. So what this means equal to 0, what this exactly means is that on the same IQ curve, level of production is always the same. So now if we find the slope of this equation right here, we will get dk by dl equal to minus, again, once with respect to L Okay, so now this is basically MPL, that is marginal production of L and marginal production of K, right? So there'll be minus sign right here. So now we have gotten in the slope of an IQ curve and slope of an ISO cost line. So if you remember what I said at the starting of the video, that we'll be creating these two equations. So that means we'll be getting MPL divided by MPK equal to, that is negative W by R. And these two negatives cancel out. So the equation that we get is MPL by W is equal to MPK by R. And this right here is our final equation. And this is what we use to basically find out L star and K star. Now, as I said, this is basically a theoretical problem, and it will be more clear when we solve numerical next. But basically, an easy way to remember this equation is basically the marginal product with respect to L divided by the cost of labor equal to marginal product of capital divided by the cost of capital. And this right here is called the equimarginal principle, right? So now let's move on to numericals, which will help us to understand the problem further. And basically, this is the solution to this problem, by the way. Okay, now. Okay, so coming to our next question. Okay, so I've been giving the following production function, that is Q equal to K to the power 0.6, L to the power 0.25. So we are already familiar what K and L mean, and where cost of labor and capital are $8 and $5 respectively. The company wants to maximize output subject to the cost constraint of $680. Find out the optimal labor with this L star, capital K star, and output Q star. Okay, so now when we first get a question, it's wise and it's very constructive to first understand the variables or the values that we have been given. So we know this is the product function, right? And we have been told that cost of labor is $8. So that is, this must be W, that is wage, and cost of capital is $5, that this must be interest, which is R. And the company wants to maximize output subject to the cost constraint of $680. And as I've mentioned before, the cost constraint is C. So we need to find the optimal amount of labor. So as you guys might have noticed, that optimal amount, this is the key word here. So whenever optimal amount is mentioned, we obviously mean that we need to find out L star, K star, and Q star. And this is where we employ the theoretical solution that we found out in the previous question. That is, we use the formula MPL divided by W equal to MPK divided by R. All right. So for this to work out, we need to first found, we also here the knowns are W and R. We already know what these values are, but we don't know what there's marginal production with respect to L and marginal production with respect to KR. So we need to find out those values first. So to find out those values, we know marginal production is basically the first derivative of the product function. So and as that is with respect to L, that is basically the differentiation of the first derivative of the product function with respect to L, that is del Q by del L. And here we are, as it is partial differentiation, we are considering K as a constant. And so if K is a constant, K will sit as it is, thus K to the power 0.6. Now, L to the power 0.25, right? This goes to the formula of ddx x to the power n, right? That is, this comes out to n x to the power n minus 1. This is basically basic differentiation. I hope you all are aware of it. So to employ this formula, so we get 0.25 L to the power 1 minus 0.25. And now if we somewhat rearrange it a bit, we'll get 0.25 K to the power 0.6 divided by L to the power 0.75. So we have already gotten our marginal production with respect to L. We need to find out marginal production with respect to K. So again, we differentiate the product function now with respect to K. So L will be a constant, that is, it will sit as it is, that is L to the power 0.25, and K to the power 0.6 will go into the product differentiation, right? Sorry, the power differentiation function. So that is 0.6 x K to the power 1 minus 0.6. Again, if we rearrange this a bit, we will get 0.6 into L to the power 0.25 divided by K to the power 0.4. All right, so we have gotten the marginal production with respect to L and marginal product with respect to K. So now we can easily input it into this equation right here. So let's do that. So MPL, right? So MPL is 0.25 into K 0.6 divided by L 0.75 divided by W, which is, as we have found out before, which is 8, equal to 0.6 L to the power 0.25 divided by K to the power 0.4 and divided by interest, which, as mentioned in the question, is 5. All right. So now let's solve that equation. So we'll get 0.25 L to the power K to the power 0.6 divided by 8 L 0.75 equal to 0.6 L 0.25 divided by 5 into K to the power 0.4. Right? And if we solve this, right here, we'll get something like this. 0.03125 equal to 0.012 L. So sorry, there'll be a K right here. And therefore, we finally get a relation between K and L. K equal to 3.84 L. So now that we have a relation between K and L, we need to input this in the equation C equal to WL plus RK, and that is precisely why the value of C was given to us. We know the value of C equal to 680, W is 8L, and R is 5, right? So that's 5K. So now if we put the value of K right here, we can substitute K for L, right? So our equation comes something to this. That is 8L plus 3.84K. Sorry, 3.84 L into 5, right? So we find the value of L. Now if we solve this equation, we'll find the value of L, and this is basically L star is 25. And if we input this value right here, we get K star equals to 96. So now we have both L star and K star, and our production function as given in the question was Q equal to L to the power 0.25 and K to the power 0.6, right? So if we input the value of L star into L and K star into K, we'll get the value of Q, which will come to 34.58. So we found out K star, we found out L star, and we found out Q star. And that is how we solve problems related to production equilibrium. I hope that cleared things up. Thank you so much for watching. If you like the video, please don't forget to like and subscribe. See you until next time.